So you can cover brief about big data, then data science and Watson Studio that is in the agenda point. Yes, yes. Nitin sir, am I audible? Hello, hello, Nitin sir.
Yeah, you're audible.
Okay, okay. Thank you very much. So I'm also recording this session. Is it okay, sir?
Yes.
Okay. Uh, Thank you, sir. So welcome all the participants. So I'm introducing the sir. Pravin Kedia is the CTO for Data and AI Experts Labs at IBM. Pravin sir has been chief architect on big data, data warehouse, replication, data integration, data science, and AI architect with 24 years of international work experience in banking, telecommunication, insurance, and financial industries across India, USA, Australia, Asia Pacific, and ASEAN. As CTO for IBM Data and AI Expert Lab Solutions, Pravin sir is responsible for technical delivery for IBM Expert Lab Services projects across hybrid cloud product portfolio. Sir regularly works with client executives and C leadership team, driving client success in product design, architecture, and deliver product implementation, support, and lead team of consultants to drive solutions to complex problems, deliver first of its kind pilots, implementations, arriving at architectural decision, deployment architecture, and scaling and enablement of the team. So here as passionate for innovation, and it is credited IBM Expert Labs offering on data fabric and governance, data stage. Sir is prolific inventor and hold third patent plateau and has continued to many studies as a part of AOT and cloud OMG initiatives. With this, I request Pravin sir to deliver the talk on the topic big data and data science. Thank you very much.
Thank you for giving me this opportunity, Amar sir. Uh, Hope you guys can hear me out properly. I am so I today I wanted to talk about big data and data science, and then introduce you to Watson, tool called Watson Studio. So today it's a hybrid world. Our clients, right, in the industry are wanting an architecture that is decentralized and open, right? They want automation, like they want everything to be automated. And they are talking about moving the lower value work to automation and have people work on more productive, high value work, right? Are our three major goals that our customers want, and they want to unlock the artificial intelligence for business and agility of hybrid cloud. So they want a platform which is hybrid, right? They want to put it in a language that can be understood by business. So we are talking about natural processing, how to prepare, how to build models, how to run models, how to manage models. how to transfer learnings from pre-training models to actual production workload, right? We are talking about doing it with trust. So whatever model you are creating, it should not be black box to the end user. You should be able to explain what the model is doing, how to measure the efficiency of the model, how to validate with transparency. We are also able to detect bias and predict, right? We also want the tool to rank models to improve. Right, whenever time permits, and they want the tool that to can run on any platform anywhere, whether it is uh, on premise, whether it is in any cloud. It needs to be run. It should be able to run on containers. It needs to be able to run on VMs. It has to be designed in a such way that it is repeatable and agile. So basically, these are some of the areas where the today's software should be relevant, and this is where I so we have a platform which has services, and on top of it we have built a software product called cloud pack for automation, cloud pack for data, cloud pack for integration, cloud pack for security, cloud pack for application management, right? So this is how IBM is positioning itself for hybrid cloud. So I just wanted to give a brief overview, right, before getting into big data key concepts. So what is big data, right? What is big data? It's a tsunami of big data, right? You might have heard of 3 Bs, 4 Bs, 5 Bs. What are these 4 Bs, 5Bs, right? So there is explosion happening in big data. So there is a lot of data coming from different sources, and there has to be a system to manage these open sources, right? So we talk about tsunami of data, right? Where what it means is we need a system which is open, right? So big data platforms are usually open platforms, right? And what it means is and it's types and formats: structured data, unstructured data, XML format, JSON format, DSON format, uh, uh, HTML format, CSV format, Avro format, right? Also, the data is coming at high speed, the velocity, right? And it impacts the business. So people are now wanting the analysis of big data to happen in almost near real time. They don't want the analysis to come after days. When the analysis is not happening, right? They want to analyze the data as they get generated within few minutes, not few hours or not few days, right? So when we're talking about big data, we also talk about the business use cases, right? So the challenges in the big data are in terms of capturing the data, moving the data, transforming the data, right? So these are some of the challenges that people would face in the big data world. Other challenges in managing the data, the hardware involved, the software involved, and how do you do processing of data from raw data to program data to provide insights into the data, right? Also, how do you safeguard the data? How do you store the data? How do you store the data? So, what is the products or challenges in the data world?
Hello, sir.
Any questions from the audience?
Voice is breaking actually.
Okay, is it okay now or is it
Now it is okay.
okay? Fine. Okay. Any questions until now or so If not, like I'll move forward. Um, you put your questions in the chat, like I will try to answer in the between, right? So when we talk about big data, what is big data, right? Data has intrinsic properties. It grows. So we are talking about like today world, 90% of data was created in last 2 years. Every 1 in 2 business leader don't have access to data they need. So these are some of the challenges that has come and that has driven the growth of big data platforms in the industry. 80% of data is unstructured. So most of our data systems are calling databases, which are but 80% of data is unstructured. How do you deal with such data? And only 20% of available data can be processed by traditional systems. Obviously, we have only 20% of data which is can be processed by traditional data warehouses and RDBMS because most of the data is unstructured. So industry CIOs are saying they need a platform which can do business analytics and this data science, right? And they need to capture or tap into this data which has not been able to tap into till now, right? Okay. So we are talking about growing world of interconnected instruments, right? If we talk about social media platforms, they are generating so much data. 300 million users are posting more than 500 million tweets per day. We are talking about 1.2 trillion Google searches per year. That's like tremendous amount of data. And all this needs to flow into the big data systems, right? We are talking about connected RFID cars, RFID devices, RFID meters, smart meters. We are talking about people hitting the web, people using the GPS, right? So all this data is typically part of the big data world. So some other examples of big data are in science, in astronomy, in medical records, genomics, biological, biochemical, social data, right? Person to person data. Tremendous amount of data is generated on Amazon.com, Facebook, LinkedIn, right? So we have so much data that can be tapped into to give proper insights. It can be used by government, it can be used by military, it can be used by telecom operators. So we have tremendous amount of big data use cases available. So people say 4 V's. What are those 4 V's? Volume, velocity, variety, and veracity. And then there is the fifth V, which we call as value. What is the real purpose of working with big data? To obtain business insights, right? And I have more V's for you, right? So this is a good infographic on the 4 V's. When we talk about volumes, we are talking about the sheer amount of volume that is there in the big data systems. When we are talking about variety, we are talking about forms of data, different forms of the data. When we are talking about velocity, the data is coming at high speed. Almost we are generating about 1,000 sensors data, right? From one particular windmill, or we are talking about billions of network connections coming in at that fast pace, right? So velocity of data is very important, and uncertainty of data, right? Again, that is very important. Velocity of data, yeah, right? You can refer to this blog which talk about 7 V's. It has added the 2 other V's called variability and visualization, right? So we talked about variety, velocity, veracity, and volume earlier, and then value. And in this slide, I introduce you to variability and visualization. So these are other problems of big data to deal with. And then I have even more V's, right? We talked about volume, velocity, variety, veracity, validity. This is another V. Is the data accurate and correct? right? Viability of the data. Is the data relevant to the use cases at hand? Volatility of data. How often data is changing? That is also another problem. Vulnerability of data. How can we keep the data secure? So we have so many V's. We can define all these as a big data problem. What is visualization? How can the data be presented to the end users? What is the value of the data? Whether the data can be used for returning the meaningful results, right? Amar sir, you are able to hear me properly now, right?
Yes, yes.
Okay,
Please continue.
okay. Any questions until now on big data like okay. So
Continue.
when we talk about the variety of data, the data could be in the structured format and can be processed in the fixed format. So that is the traditional table, row, column format. Semi-structured, the data does not have formal structure. So basically picture really, it could be like semi-structured and it is totally unstructured, right? That is what these three. So we are talking about, when we talk about semi-structured, it could be XML, it could be JSON format, right? It has some tags and the metadata in the data. And then the third category is totally unstructured data as unknown format, cannot be stored in RDBMS, cannot be analyzed unless it is transformed into structure. So this is usually the text file, the multimedia, content, images, videos, audios. So we have so many use cases in the real world: facial recognition, audio recognitions, mapping of digital fingerprints, right? Doing analytics on those kind of data, right? It is really, really very, very important to analyze this kind of data. There are so many other examples of documents getting crawled, right? So we have a product called Watson Discovery that can crawl the documents, unstructured data, right? And do the analysis, right? So there's, so basically when we're talking about big data, these are some of the variety of the data that we need to work with. And this is the big data analytics technique, right? You will always start with some problem, right? You will always start with some problem. You will analyze the business. Then you will create a business strategy. Then you will create a domain knowledge. Then you will communicate your knowledge, present that knowledge, and then there will be some intuitiveness on the knowledge. And then again, so this is a cycle, big data analytics technique cycle, right? And then there are these tools to help you. The core tool on data science, right? Data science is the core tool. And around that, we have visualizations, statistical tools, pattern recognition, machine learning, AI, data mining, database and data processing. We have neurocomputing, right? All these are the tools around the data science. And these are all in the big data analytics techniques, right? Top 5 use cases of big data, right? So we have the big data exploration zone where we need to find the data, visualize the data, understand the big data to improve the decision making, right? So this is the big data exploration use case. We are talking about the enhanced 360-degree view of a customer. So we want to know existing customers, understand the existing customers through internal and external data sources, try to find out what are their needs and position them new offers based on our requirement, their requirement, right? So this is a very important use case of big data and it is very loaded, right? We are talking about external and internal data, right? About the customer. And probably this is what is most of the big data problems that you might be seeing in the real world. Other kind of use cases on security and intelligence. You want to use the big data tools to lower the risk, detect the fraud before they happen or while they are happening, monitor the cyber security in real time. So this is a very important use case again from security point of view, which only big data can solve. Operational analysis, analyze the variety of machine data for improved business results, right? And third, last use case is the data warehouse augmentation, which is obviously using the big data platform as a lower cost platform to increase the operational efficiency. Right? So you will still have your traditional databases, data warehouses, and data lakes, and you will use big data as part of the data warehouse augmentation. Any questions until now on the big data concepts? Anybody? If you guys are not understanding anything, please let me know. Okay, I'll move forward then. So we will need the common use cases, right? These are some of the common use cases that will apply to big data. We'll talk about, when we're talking about big data, we need to talk about the extraction, transformation, and loading tool, or we need to talk about extraction, load, and transform. So in traditional world, we usually do extract, transform, and then load, right? That is usually what we do, ETL. But when we talk about big data, we will see that we will extract the data, load the data, and then transform it inside the big data platform. So we are using ELT technique, right? Then we also talk about text mining and index building. That is the only way for us to analyze the unstructured data. And then we talk about graph creation and analysis. So when we talk about big data, we also want to talk about graph database and graph platforms, right? Then pattern recognition is important concept on big data platform. Collaborative filtering, predictive analysis and modeling, sentimental analysis and risk assessment. So these are some of the tools that when we are like in traditional databases, we would not talk about this. We will talk about these on the big data platform and the big data problems, right? And this is very good way of representing the today's world. Data is the new oil. Oil is supposed to be the most costliest system in the world, right? And today in the IT world, data is the new oil, right? So if we have data, we extract the data, we analyze the data and gain knowledge from it, gain insight from it. That is what will help today's industry move forward. So data is the new oil. Okay, and other big problem in the big data is about real-time analytics. So this is where we need to talk about big data platform for doing analytics on real-time data. So we need to do analysis of data as the data gets generated. And when we talk about sub-second, it usually means few seconds, right? So we do, so really big data system, whether it needs sub-second response time or human comfortable response time, right? So I would say most of the big data platform would say human comfortable response time. I would not want to say sub-second response time because the purpose of big data platform cannot be sub-second response time. We usually couple of seconds is what these big data platforms are designed for. So we call them as human comfortable response time. And then we are also talking about event driven, right? It is opposite of scheduled, right? So whenever some event happen, then you need to do the processing in particular time interval. All right. In telecom industry, it is always event driven, right? If you have some call drops or even in internet, right? If my internet connection is not stable, then I need, if my internet provider is really looking for me to get benefit from his internet connection, he would detect this event in real time and do something about it so that my internet performance improves, right? My internet connection don't get dropped. So that is like event driven, like they do real time analytics and find out what is the cause of my internet being slow or internet getting dropping, right? Or my call record getting dropped. Then we also talk about the streaming batch processing. So this is very important tool in big data. We are talking about tools like NiFi. We are talking about the streaming analytics tool called Storm, right? Streams. There is another tool called IBM Streams, right? So we are talking about doing the real-time analysis, which is opposite of batch processing, right? So when we talk about streaming data analysis, we are talking about analyzing the data in the on the streaming. So one good example of this would be the stock price and algorithmic trading, right? So they work on the streaming data to give you the tips on the stocks, whether they are going up or down before they actually happen, right? So that is again a big data. Every second your stock pick changes, right? Your volume changes for our BSC and NSC stock exchange, right? So that is a very good example of doing streaming data analytics to predict the stock prices. And when we talk about big data ecosystem, the most common tool is Hadoop, right? Which is constantly changing and getting updated, right? So when we talk about Hadoop, there are so many other kind of things that comes into picture. So in this chart, I am not going to go into detail of a lot of it. When we talk about Hadoop, there are distributions from IBM, Hortonworks, Cloudera, Oracle, Mapr, Apache, AWS. So everybody has different distributions from the same open source Hadoop. And then we talk about the HDFS file system, which is Hadoop distributed file systems. And then in the Hadoop, the concept is each and every data is replicated 3 times. So, so the idea behind Hadoop is the data is always going to be available, right? Even if some worker nodes go down, the data will be available from other worker nodes, right? And the concept behind Hadoop is parallel processing, right? Parallel processing. So we talk about MapReduce, which is the core to the Hadoop, how the files are getting, how the analysis happen on the Hadoop HDFS file systems, right? And then there were other versions of Hadoop, Yarn, there was MapReduce, Yarn, and now future restrict versions V3 is come out. Okay, so how to put this all together, like just one chart to describe the big data platform. There will be data coming from databases, sensor data, RFID data, Facebook, social media, mobile apps, smart meterings, Twitters, right? So there has to be a system to do the streaming data analytics, where we call them as ingestion and real-time analytics zone. Then there has to be some system for managing this data coming at fast speed, and we should have a system for Hive or HBase. The Hive is basically the row and HBase is the columnar, right? So we need to have some row and columnar data stores. Then we also need our traditional data warehousing solutions and data mart solutions, right? So we are not saying Hadoop will replace these data warehouses. They will augment these data warehouses. And then there will be other analytics and reporting zones where data will be processed and reported upon. The data will be analyzed using the predictive analytics. And then there will be a tools to visualize and discover the data. Okay. And then obviously there has to be metadata and governance zone on which all this happens. So when we talk about big data problems, We are talking about streaming data. We are talking on text data. We are talking about application data. We are talking about time series data. We are talking about geospatial data, the location data. We are talking about video and audio images coming from CCTV and whatnot. And we are talking about relational data and also social network data. All this needs to get ingested and operationalized, right? There has to be some real-time analytics zone, and there has to be some long-term landing and archive zone. And on top of it, there has to be some data warehouse or mart zone and analytics appliances to do the analytics on it. And all this should run on the governance platform. And on top of it, we need to run the data science, whether it is cognitive, whether it is prescriptive, whether it is predictive, whether it is descriptive analytics, or we want to just explore and discover new things. So when we talk about cognitive, we are talking about learning dynamically the new things. Prescriptive, what is the best outcome? So what if analysis can be done in the prescriptive analysis? Predictive, what could happen, like, right? Descriptive is what has happened and what do they have, right? That is the exploration and discovery. So this is very important data science concepts. And then there has to be tools like Watson, alerting, case management, cloud services, ISV solutions, right? So all these are the broader picture on the data analytics. So when we talk about big data, we are also talking about machine generated data, natural language. We are talking about talking voice to text and text to speech, right? We need tools for that. We also need to deal with the tools which generate graph based data. We need to talk about audio, video, images, right? So Hadoop is just one of the systems to handle big data, right? It is an open source framework, right, which can deal with massive amount of data with parallel processing and MapReduce, right? And it was meant for heterogeneously commodity hardware, right? Supposed to run on that. And then the Hadoop ecosystem is growing every day. We have more than 50 open source or even 100 open source projects on Hadoop, right? And they are getting used by our customers in the industry for different purpose. Okay, this is very important slide where we talk about where or why Hadoop is used or not used. So Hadoop is used when we talk about massive amount of data through parallelism, when we are dealing with variety of structured and unstructured data, and we are talking about inexpensive commodity hardware, right? Hadoop is not good for, very important to note, for process transaction. It's not good when work cannot be parallelized. It's not good for low latency data access. It's not good for processing lot of small files. It is good for processing large files. Not good for intensive calculations with little data. So Hadoop is not the only solution to deal with big data, right? So we should know when the Hadoop is to be used and when it has to be avoided. And Hadoop paradigm is different. We have to start thinking differently. We have to start thinking about ELT, right? Extract, load, and transform rather than extract, transform, and load. We are talking about storing different types of data, right? And in different formats. And we are also talking about different parallel processing paradigm. So when we talk about Hadoop, we need to think differently, right? Okay. So this is another chart which tries to compare the Hadoop versus RDBMS, right? So when we talk about majorly the languages in RDBMS is majorly SQL, but in Hadoop it could be like Pig or Hive SQL, or it also could be IBM Big SQL or Impala or Spark SQL, right? And other major difference is compression. So we have simple file compression in HDFS. What in database you could have complex, sophisticated compressions, right? Okay. So when we talk about Hadoop, we talk about partial failure support, right? These are the new requirements for this Hadoop. Data recoverability for Hadoop, component recoverability for Hadoop, consistency of data, scalability of data, right? So these are some of the requirements for Hadoop. And Hadoop is basically based on the Google file system, which happened in 2003, and MapReduce, which happened in 2004. So these are the inputs going into the Hadoop. Okay, so that was big data. So now, do you have any questions on big data before we move to key concepts on data science? Anybody? Okay.
Sir, I have a question. If one of the node in Hadoop is crashed, how it is
Yeah.
handled by the
Okay.
Hadoop system?
Yeah. So in Hadoop, I said like every data is 3 times replicated. So even if one node crash, you will have the data in some other node. And we have a concept of master node, right? Node manager. So that node manager will actually locate the data from other worker nodes and give that data to the users. And then later on, when you bring up the old server back up, then the data automatically gets replicated to the new server. So you don't have to manually copy it.
Okay. Thank you, sir.
Okay.
Let us know if there are any questions from faculty members.
Yeah. Any questions, please ask, or you can write in the chat. I can take it up. Okay, let me move forward on the data science key concepts. So when we talk about data science, we are talking about AI. But what we are saying is we cannot have AI without IA. What is IA? Infrastructure, right? So without the proper infrastructure, right, you cannot have AI, right? So you need a data system where you can collect the data, make the data simple and accessible to everybody, right? You need a system where you can organize the data so that people can trust the data that you are working with. People can find the data you're working with easily, right? And then there is a need for doing analysis of the data in the scalable manner, right? So you need a platform where you can do insights with AI, right? And then you need to grow with AI in such a manner that everybody trust the data. That means you are operationalizing AI with trust and transparency. That is the infuse stage. So you want to reach the infuse stage if you really want to modernize your applications. So you need AI. If you need to have AI, you need to have IA, right? So that is how you will reach AI. So IBM has this platform we talked briefly about, which is Cloud Pak for Data, which is sitting on top of the hybrid cloud platform on Red Hat OpenShift, which is the Kubernetes platform, Docker and Kubernetes platform. It's a cloud native service. And then there is a single product to install called Cloud Pak, where we have many other components that can get installed, like Watson Studio, Watson Machine Learning, Watson Auto AI, Watson OpenScale, right? And then we have the software and AI application sitting on top of it. And then we have the Watson to infuse AI into the business, right? So this is how people are advancing on the AI journey. They start with these kind of requirements: AI interfaces, pseudo AI, AI skill, AI bias. Then they move up with the chart and they become an expert from assistant. Then they are peer, and then they can mentor others in the industry. So everybody wants to reach this stage of advanced AI, right? When we talk about auto AI, we talk about context aware AI, we talk about AI abstraction, right? So these are some of the dimensions, and all of these should be on the governed platform, right? Okay, this is a typical crisp topology for data science. We always start with business understanding. Then we do data understanding, and we may go back and forth many times from business understanding to data understanding. And then we do use the statistical data processing, create the modeling. There will be again back and forth between these. And then there will be model evaluation and then deployment. And then we are talking about monitoring. So this is the typical life cycle. And when we talk about the business understanding, we talk about what is the success criteria, what is the business use case. When we talk about data understanding, we are talking understanding attributes, what is the knowledge and the governance catalog. We are talking about exploration of data, characteristics, what is the exact characteristics of data, what are the outliners. When we are talking about statistical data processing, we are talking about sampling the data, feature engineering the data, doing the unsupervised learning, reinforced learning, right? And then when we are talking about modeling, we are talking about supervised predictive modelings. When we are talking about evaluation, we are talking about confusion matrix, cross validation, right? Then when we are talking about deployment, we are talking about REST API and pipeline. And when we are talking about virtualized data topology. So this is typically the data science workflow for handling the big data problems. Any question on this chart? Okay. So when we talk about big data, data science, we want to talk about the lingo and the life of data scientist. What are the main steps in typical data science workflow and how people do the data science? So when we talk about terminology, we are talking about features and attributes. So this is basically the input data for machine learning model. Then we are also talking about output variables or target variables that you are trying to predict. When we are talking about unsupervised learning, we are talking about no goal or no correct answers are provided. We are uncovering the data based on the uncovering the reports based on the data. When we are talking about supervised learning, we want to find out the correct answer. We want to predict certain values. And what is data science? It is used to collect or mine the data. So when we combine the big data with data science platform, it is really going to be the main platform for our century. Next 10 years, next 20 years is the data science century, big data and data science century. Okay. So when we talk about data science, we need to go through these all the steps, right? What is the methodology that we are going to use for doing the data science? What is the business understanding? What is the data understanding? How do you prepare the data? How do you model the data? How do you do the evaluation of the models that you have built? How do you deploy your model in the production? So when we talk about business problem, right? How do you identify the business problem? To identify the data science use case, First, we must decide on our business problem. What is the situation today? Where are the areas for improvement? What would be the impact if we change the data? Then we need to go to baseline metrics. How do you measure the performance of your model? How good the solution is at predicting the correct outcome? The metrics itself varies depend on the type of the problem. So depending on the problem, your metrics might be different. So examples, how accurately you want your model to predict the sales demand for gas turbines? How many new articles mention about some company? What proportion of images are correctly classified with the current approach? Right? These are all some of the performance matrices. Whichever is chosen for machine learning model should be used to calculate the performance bias. Then we also need to talk about time. This is the duration it takes to complete this task. How long it takes without the machine learning model and how long it takes if you do this manually. So you need to find out the value of it. How long does it take for human to manually review the text and highlight the key information? Instead, we have a tool which can actually do this for you. So such tools can be useful in lot of analysis, right? Like people can highlight the medical history, people can highlight the FIRs, police records, government records. How quickly you can respond to trends. Then another aspect is about money. How much more money is lost due to late machine breakdown prediction? How much revenue can be generated by opening a new data store, new store, right? So whatever recommendations you are making, how much revenue can be made? What is the cost of having a person manually do this task? Then we spend some time physically looking at data quality. It's a very important prerequisites to ensure feasibility and scoping. What data is being used today? What data will be available? How much data will be available? How will this data be extracted? In what format it will be presented? Then we do data exploration. How many records do we have? We need to provide meaningful summary of data. Is there any missing data which is required by our tools for proper analysis? Or all the data is available for me to do analysis? Are there any outliners in the data that I need to look at? Is the data that I have is balanced and representative of across all the data that I will get in future? I need to take the data which is unbiased, right? It should be covering all sections of the data. It should not be biased towards certain prediction. Is the data balanced? Is there any bias? Are there any omissions in the data? So these are some of the things that we would cover under data exploration. Then we need to work on data cleansing, filtering the right data, formatting the data, removing or replacing the missing values, balancing the data sets, removing the bias, processing of incorrect or corrupt data, remove inaccurate and unwanted records. So these are some of the things for data cleansing. Then when we talk about modeling or data science, we also talk about something called feature engineering. Translate human knowledge to machine learning features. So here we need to be creative. Good model requires good features. So we need to brainstorm on what features are most important for our model to be used by many people in our organization. We need to decide what features to create or derive. Decide which features to remove. We might say that out of 10 features, only these 4 features are most impacting. So if you use more features, probably you will not be able to explain a lot of things on your model to your end users. And then end users may not use your model, right? So you need to keep your model simple so that simple and relevant, right? You need to encode text or category data. Then next thing is about underfitting and overfitting. You want the data to not be underfit or overfit. You need thing to be optimum. You need the data to be optimum fit rather than underfit or overfit. So your model should be optimum. It should not be underfitting or overfitting. When we say underfitting, it means we have high bias, and we have overfit means high variance. Then when we talk about model, there are some standard techniques for classification, association, segmentation, right? So we need to see next. So we need to evaluate what techniques we will use. Then how you will choose between different models. So that is the next thing. How do you select the optimal model tuning parameters? How model can be configured or tuned by adjusting the hyperparameters of the model. So you need a platform to evaluate your models, right? How do you determine which is the best feature to select from the model? Some features are highly correlated. So you see these two features are highly correlated with other features and may bias or skew the model training. So you want to remove such correlated features. Some features might introduce more confusion rather than help the model learn. Some features might introduce bias that legally discriminates against minority or protected group. So these are very important things to analyze when you build the model in the real world. Companies are losing a lot of money because their model is biased. You might have heard that. Use model evaluation procedures to estimate how well the model will generate the output of the sample data. Need to avoid overfitting and underfitting. We also need to have cross validation. So we should use probably k-fold cross validation technique to minimize the variability of data. So what we do is in experiment 1, validation is done with the first, and these are the experiment data. In the experiment 2, validation is done with that second. In experiment 3, this is what is used for validation. Experiment 4, this is used. Experiment 5, this is used. So 5-fold cross validation is what we do. So when we talk about model evaluation metrics, when we talk about classification, we are talking about accuracy of a model, precision of the model, recall of the model, F1 score for the model. When we are talking about regression, we are talking about roots mean square error or mean absolute error. And when we are talking about clustering, we are talking about log likelihood or perplexity error. So if you see what is classification, we are saying this photo is of a cat. This photo is of penguin, right? So that is like classifying. If you see this example, we are talking about regression, right? So which of these products is likelihood to be, like if I have t-shirt and summer vacation, probably the sales of t-shirt will go up when there is sunny summer vacation. When there is a sun, right? Weather is good, then there will be high sales of t-shirts, right? So that is what comes. Or in the clustering, we have basket of products, we want to cluster them together, right? So these are some of the modeling techniques. So when we talk about model evaluation, the most important thing is the F1 score, right? So F1 score is the most important thing, right? And we talk about that is accuracy of the model. How often is the classifier correct? Miscalculation rate, how often it is wrong? Recall, when it is actually yes, how often it predict yes? So this recall should be high. False positive rate should be low. When it is actually no, how often it does predict yes? True negative rate, when it is actually no, how often does it predict no? False negative rate, when it is actually yes, how often it predicts no? Precision, when it predicts yes, how often it is correct? So how often it is classified correct? When it is predicted yes, how often is correct? So there is a difference between accuracy and precision. Null accuracy, how accurately this could be achieved by always predicting the most frequent class. Then we talk about model evaluation using the mean absolute error and root square error. So these are some of the, so lower these values, better the model is, right? Then how do you deploy these models? This is another consideration. So making the model do the prediction and classification easily available to business. Measuring the quality of the deployed models. Tracking model quality over time. Monitoring the model. So these are the some of the things when we want to uh, make your model live in any organization. Okay. When we talk about deployment, right, we also need to talk about how do you deal with historical data. So in this chart, we are talking about how we develop the model, evaluate the model, train the model. So this cycle continues. Once it becomes stable, we want to deploy the model in the production environment. So the trained model gets deployed in the production environment, and then it generates some actionable insights. And based on the insights, people would have some feedback that would go back to the historical data. Similarly, when some live data comes, it might also give some. So the same live data will go into the historical data, which will help in the model development. So this cycle continues, right? This cycle continues. So for your model, like if you develop a model today, after 1 month, that model may not be relevant. So you need to have this constant feedback going into the development cycle. So IBM does have a tool called Watson Machine Learning to handle this deployment and the feedback loop. All right. So it's a very important in the data science. Okay. So summarize, right? These are the goals or what should be in a data science project. Agree to the goal or baseline with the business. Understand the data, cleans the data, ensure appropriate algorithm and matrices are there, train with enough data, build relationship with subject matter expert, start simple and be wary of too good to be true. If your model is always predicting properly, then that means your model is not good. So you need to be worried about that model, right? So too good to be true. So any questions at this point of time? Anybody before I move to IBM tool on Watson Studio? Okay, if no questions, so I just want to talk about one tool from IBM called Watson Studio, which is going to help you with data science and big data. So Watson Studio is a data science tool. It provides collaborative integrated development environment encompassing various components to manage, create, deploy machine learning models, right? So it's a IDE, right? Simple word, it's a IDE to help you to manage, deploy, create models. It can be employed in cloud, standalone, or desktop, right? It's a complete environment for data management, modelization, and visualization. It helps in the big data analytics, right? It helps to cater to the V's that we talked about. It has the pre-built capability for building statistical machine learning and deep learning models. It is having heterogeneous libraries of open source. It code based and graphical modeling, execution, data at source, offline patterns. So when we talk about Watson, the key features, we talk about collaboration, like multiple users can develop simultaneously on the same platform. They can all collaborate on the same project. They can have some roles like admin, editor, viewer, right? So those kind of roles. Or we also have something like, so basically your data sources, then your community, the catalog, and the optional services. So when we talk about community, we have the data files, connections, folders, flows, notebooks, AI functions, dashboards, your experimentation, auto AI experimentations, right? When we talk about tools, there are tools to prepare data, develop and train models, stream data, manage compute resources. So you can actually create notebook with 2 GB RAM or notebook with 4 core and 8 GB RAM, right? Depending on your requirement, you can create different kind of notebooks on the Watson Studio. Visualize the data, schedule the jobs, optimize the decisions, automate the model development, classification and images, train neural networks. All this can be done on the platform. So environments, we have default Anaconda for R and Python, right? You can also have Spark environment for big data sets. So when we are dealing with big data, we will use Spark because Spark does everything in memory, right? And the Spark can be using either Python, R, or Scala. It also has RStudio. You can also use RStudio on the same platform. You can also do customization of your environment by adding the libraries or upgrading or downgrading the libraries. Okay. So this is this is the Cloud Pack for Data URL, right? And on that you are running the Watson Studio, and this is what you can do: deal with the data, do an auto AI experiment, create a model from file, metadata import. You can also create a notebook. You can also do federated. You can also use something called data refinery flow. right? And then you can also use the SPSS modular flow, right? So these are some of the features on Watson Studio. And you can also use and connect to different data sources. Both IBM and non-IBM data sources can be used. HDFS, Cloud Object Storage, Cloud and MongoDB, Informex, Netezza, SPSS, MQ, any of those sources can be there. And the data refinery can be used to do cleanse the data, remove duplicates, ensure correctness, shaping the data, splitting the data, those kind of functionalities. Okay, so notebooks. So these are the notebook environment, and then this has the different kind of notebooks. So first one says 2 core and 2 GB RAM. The next one says 1 core and 8 GB RAM, right? So that kind of different notebooks can be created. And your notebooks can be either Jupyter or Zeppelin notebooks. Jupyter is the older one, Zeppelin is the newer one, right? It also, you can run this as Spark or SPSS predictive analytics algorithms, or there is a IBM product called DO, decision optimization. You can also generate the code. So advantage with the Watson Studio is there is some drag drop functionality, and if you have the connected sources, like you can just drag drop and the code will get generated. So that has a very powerful idea to help people develop the code in the notebooks. You can also run the notebook on demand or schedule them, and you can share and publish notebook in Git. So you can have Git integration of these projects. Okay, you can do drag drop based model creation. So you see the different models are here, right? Bayes, Chad, right? Auto classifier, all those models you can drag drop and create. Visualization tools. We have a lot of visualization tools that can be used on the Watson Studio, like Matplot, Terraforms, Pixie Dust, GraphX, Drunal. We also have Cognos embedded visualization on the platform. So it has a lot of tools to deal with the ways that we were talking about earlier in the big data problem. Decision optimization, basically we can do mathematical and constraint based programming using DO. So we can also do linear optimizations, simplex handling. Any question or?
त्याच्यासाठीच माझी ते हिंमत होईना ते चॅप्टर ओपन ते दरवेळेस ते लफडं असतं किती पर्सनल कनेक्ट वर आता किती होते त्या दिवशी 240 लोक होते.
Any question, or you can go on mute maybe. Okay. Then we are talking about rule based optimizations, right? Rule based optimization is what mathematical or constraint programming would be, right? So you can do those on these Watson Studio decision optimization libraries. Then there is a tool for auto AI. So we can, on this platform, I can do auto AI experiments, automatically process your data, select the best estimator for data, and then generate the model pipeline. So it takes your data, takes your features, and try to predict what is the best model, right? And gives you the options, right? It comes up with the top 3 models that would give you the best performance, right? And then it will tell you like this is the model. You can actually check that why is that model the best one to based on your input variables and the output variables. So how does Auto AI work with IBM Studio? So this is where we are talking about. So here if you see there are 12 pipelines that were evaluated and the top 3 pipeline were predicted, right? So it is integrated with Watson Studio and Watson Machine Learning. It automatically ingests, cleans, transforms the model with hyperparameter optimization. And the training feedback visualizations are provided in real time to see the best model performance. So it's a one click. So even if people don't understand the model, right, they don't have understand the what is the regression technique or what is the um, technique behind k-means clustering, right? With this auto AI, the life for those normal people who don't understand these complex statistical algorithms becomes easier. They will still get the best tool or the best model to select from automatically. So they don't need to really know what each of these techniques work or how they work, and still get the best model to work with their problem in hand. So Auto AI really works with the labeled data set. It prepares the data, does the model selection, find the top K estimators, does the hyperparameter optimization on selected estimators, find the best features, that is also called feature engineering. And then we also do hyperparameter optimization after feature engineering. So at the end of it, we get the best model. So benefit of Auto AI is build the models faster, jump the skills gap, discover more use cases, find the signal from noise, rank and explore the models, ready, set, and deploy the model. So this becomes easier for people who don't know those statistical models and still want to do data science experiments. So it is as simple as automated data preparation, feature processing, model selection, rank models, right? So you upload the data in the CSV file, it prepares the data, feature detection, missing values, imputation, feature encoding and scaling. Then it does the model selection based on the best estimator for the data. Then it does the hyperparameter optimization and optimize feature engineering, generate the ranked model pipelines, save and deploy the model, right? So this is the experiment that can be used in the Auto AI. So with this, I want to stop for today and give back the time for question and answer. Any questions on big data and how data science can be used in the big data world? Any questions from the participant?
Sir,
Please
I have
ask.
a question. Whether, hello, am I audible?
Yeah, I can hear you.
Okay, whether Watson Studio is open source
Uh,
or the paid.
Watson Studio is the IBM product, so it's not open source. But if you create an account on cloud.ibm.com, you can use some of the services for free. So you for like if you are not doing like a lot of working with lot of data, then probably you can use the Watson Studio service on cloud.ibm.com. Let me show that to you.
Okay, please.
So you can go to cloud.ibm.com and sign up with your ID. So you need to create your ID, and while creating the ID, you can they might ask you for your credit card, but they will not charge your credit card. Okay. So just to create the account, maybe they'll ask for your credit card information. So yeah. So here you can go to cloud.ibm and you can sign up with your college ID also. So
Okay.
college email ID should be good enough, right? So yeah. So let me just put. So once you have the account, you should be able to go to the cloud.ibm.com. Okay. And then you can create a Watson Studio. Okay. So if you go and create, so there is a light plan for Watson Studio. See that light plan? It is free, right? So
Okay.
once you simply go there and then just say create. Okay. So once you do that, you can actually see that service in your account, and you can start using this Watson Studio.
Okay.
So even Watson machine learning, Watson auto AI, all that you can actually do from here.
Okay. Without knowing any details of the particular algorithm, right?
Yes, yes. We
Okay.
can use Watson learning, right? Then Watson auto AI. So you will, the services will appear in the services. Yeah. Okay.
Okay.
Yeah. Okay.
Okay, Nitin sir, do you have any question?
Yeah.
Okay.
Please go ahead and ask. Yeah. Yeah, I think there are a lot of courses on cognitive, I think IBM cognitive classes. Yeah. So we have a lot of courses on cognitive classes, right? Yes, yes. So there are a lot of courses on data science, Python, Docker, Kubernetes, deep learning, right? Big data. So so many courses are there, and you can benefit from that. I put the link in the chat, and the other link is the cloud.ibm.com. Any other question? So this is how cloud like this appears, and then you can actually create a project, right? Work with data, right? Right. And then you can create a new notebook. So you also have R Studio, or if you want to work with notebook, you can also do that. New. So this is what I was showing you in the, so data refinery, data replication, federation, Jupyter notebook, right? So definitely, I think you guys can explore. I think more on this. Any other questions? Like,
Sir, these courses are free, right?
yes,
Okay.
yes.
Okay. Very good. Participants, you can ask any question.
So I have created a notebook, and then I can run the Python code in it.
Okay.
Okay. Okay, if no other questions, probably we can stop, and like
Yeah.
if you want, I can have another course on like other Watson tools like in future.
Okay. Sure, sir. Yeah. So I request Dr. Nitin More sir to give vote of thanks.
Yes.
Uh,
Thank
Thank
you.
you, sir, for giving valuable time. You covered the basics of big data, data science, and medicine students.
Yeah.
Thank you, all the participants. Thank you, sir. Thank you very
Thank you. Thank you.
much. Yes, thank you. Okay.
Thank
So I'm stopping the screen.